Now we're going to look at another AMC 10 question. This is 2017 AMC 10A problem, problem 22. Okay, so sides AB and AC of equilateral triangle ABC are tangent to a circle at a point B and C respectively. So what is fraction of the area of ABC left outside of a circle? Okay, so we're going to look at a fraction. Okay, let's graph this. All right, we have a circle, we have equilateral triangle ABC, and we know B and C the tangency to the circle. Okay, so we know the tangency is very important for a square, right? So then when you connect the center of the circle and the tangency, that's must perpendicular to the tangent line. So this is right triangle, this is also right triangle. Since we know this is a equilateral triangle, this is 60 degree, we can know immediately this is 120 degree. Why? Yeah, so you can see this is a quadrilateral. The sum of all angles is 360. We have two right angles, 180. The rest 60 and 100. And this angle must add together to 180, right? This 60, this 120, right? So this is a very important property of this picture. All right, so what the question asks about? The ask about is what a fraction of area of ABC lies outside of a circle. Okay, so what a fraction of ABC? ABC is here. I'm going to draw a this red triangle, right? So this, what a fraction of this is outside of circle. Circle is here. Circle is here. Right? Circle is here. So then outside will be this part. This part. This is outside. Right? So basically they are looking for the green is what part of it. So the green up over the red triangle, right? I'm going to put it. This is the question asked about, right? So if we know the side length, let's say we can assign any number, right? So we just need to know what this is, right? Okay, so but how to find this green strange shape? Yes, we have a way to find out, right? We can use this equilateral triangle, subtract this crescent part. So let's see. So we're going to subtract this part and put this part in blue. So subtract this shape. How to find this shape then? We raise another question, right? Okay, so that won't be hard because we already see how to solve this, right? So we actually, this is inside of this circle O, inside the circle O, but we can use this sector, a part of this sector, right? Part of this sector. Then we can use this sector, subtract this triangle. Subtract this triangle. Subtract this triangle. Then we got this, right? So I'm going to started working on this. So these actually equal to the sector subtract. So I didn't draw very well. So I'm going to look better. So like this one, right? Minus the bottom one will be minus this triangle. Okay, so if we can do that, we can find this area of this triangle, we can find the sector, so we can find the blue. We find the blue crescent-like So we know the triangle area of this triangle. I think I like to change this to right color. Right color. So then we can find the this is equal to the blue, right? Okay, so then we can find this, right? This is the overall plan. Okay, so then we're gonna work out. So first we're gonna find this part, and then go 2, and then we go to 3. First part is this, right? We can simply let the radius of this circle be 1. Let's make things a lot easier to do the calculation. So now we can find the sector. So to find the sector, this part is gonna be the sector here, right? So sector equal to the angle here, the angle over 360 degree times pi r squared, r just 1, right? We can, let's temporarily put here, right? So then what is the angle? Yes, we just talked about this is 120 degree, right? So you can see this nothing but just 1/3 pi, 1/3 pi. Then we can look at this triangle here. How to find this triangle? A simple way is because we know this side, these two sides, we know this angle, we can use a formula called 1/2 of the two sides, 1 times 1 times sine of this angle, sine 120 degree, right? So if you know this, that will be much easier. If you don't know, but we do have a shortcut. So I think we're going to talk about this shortcut. So the shortcut could be, so, this is 120 degrees. So then this one, because this is isosceles triangle, this 30 degrees, this 30 degrees. So we can simply draw a height from the center to this. Then this is going to be a perpendicular bisector of this ABC, and also each side of this OBC is a special right triangle, 30, 60, 90. So that makes things a lot easier, right? We can find, since this one, the height is going to be 1/2. This is 1/2. So then we have, this is 1. This is 1/2 because it's 30, 60, 90 degree. So this one is square root 3/2. Right? So, but we have another half. So this one is square root 3/2 as well, right? The height is 1/2. The area of this, then that will be minus 1/2. So the base gonna be square root 3/2 plus square root 3/2. That's square root 3 times the height. Height is 1/2. All right. So then that's not very hard. That's a square 3/4. All right. So now we got the first step, right? We know what the blue part is. So now we need to find the area of triangle, subtract this blue part. Then we got the green part. What is the area of this equilateral triangle ABC? Right? So we know the formula, right? So triangle ABC as area, we can use side length S to find it. If we know the side length, the area going to be square root 3/4 S squared. All right. So, but we don't know the side length yet. We can go back to the graph and find out. So either way, just we connect O and A. So remember, this OC is connected the center to this. This is a perpendicular. Actually, this is right triangle. So this is 60 degree. Each side is going to be 30 degree. This 30 degree. This is again a 30, 60, 90 right triangle. This is one. So this side is 2 of these. This is going to be square root 3. The silence actually equal to 3. So then we can find this is going to be square root 3 over 4 times square root 3 squared. So then that will be 3 square root 3 over 4. Right? So I'm going to put here, this is 3 square root 3 over 4. So we know this part. This part is minus pi over 3 minus square root 3 over 4. Okay, so now we need to simplify this part. Okay, so this actually equal to, you open the parentheses, change the sign, you're going to see that's going to be square root of 3 minus pi over 4. Pi over 3. Yes, pi over 3. Right? Now we have only one step left. So we're going to find the ratio. The ratio is just like this. The green part is square root 3 minus pi over 3 divide 3 square root 3 over 4. We can multiply 4. So then we got 4 square root 3 minus 4 pi over 3 over 3 square root 3. So still need to simplify. Multiply square root 3. Multiply square root 3 equal to, so the bottom one goes 3 times, this is 3, right? 9. The top one going to be 3 times in. That's 3 times 4. That's 12 actually. Minus 3 square root 3 pi over 3. So one step, 12 divided by 9. That's 4 over 3 minus this one. Oh, this is 4. Sorry. Yeah. All right. So then this one actually equal to 4 square root 3. 3 times 9, 27. 27 pi. Yep, that's gonna be our answer. Okay, go back to the choices. So you can see E is exactly what we got, right? So now we got our answer is E.